Okay, so have you ever been watching a video or, in the middle of some important meeting online
Oh, yeah.
and then bam, the connection just drops?
All the time. Yeah, it's so frustrating.
It's the worst. So today we're going to dig into how networks are built to try and stop that from happening. Like how do they make sure things keep running even when stuff goes wrong?
Right, we're talking about fault tolerance, basically.
Exactly. And you sent over these really interesting transcripts from Code Curious, those AP computer science videos.
Yeah, they had a whole section on fault tolerance.
It was super insightful. And I think for anyone listening today, we all use the internet all the time. But how many of us actually understand how it manages to stay up and running even when things break?
Right, it's kind of mind-blowing when you think about it.
Totally. So we're going to explore those fundamental principles of fault tolerance and how they apply to the internet. What are the strengths? What are the weaknesses of different approaches to building these networks?
Yeah, and that first Code Curious video starts with a really simple example. Imagine you've got 7 devices, right? And they need to communicate with each other. They show this by connecting them all in a line with 6 wires. So it's device A connects to B, B connects to C, and so on, until you get to F connecting to G.
Ah, okay, so it's just a straight line of connections.
Exactly.
But then doesn't that mean that if A wants to send a message to G, it has to go through B and C and D and E and F?
Yeah, exactly.
Oh.
That's the thing. It can work, but it's not exactly efficient.
No, not at all. I mean, it's functional, but not ideal.
And then they contrast that with what if every single device was directly connected to every other device? So a fully connected web.
Oh, wow. So then A to G would be instantaneous?
Exactly.
Yeah.
And so they pose this question, which one's better?
Interesting. Because on the one hand, you've got the linear setup, which uses fewer wires, so it's more resource efficient. But on the other hand, it seems way slower.
Yeah, and that's the thing. They point out that this efficiency with the linear setup comes at a big cost.
Oh, I see where this is going. This
Yeah.
is about fault tolerance.
Exactly. So
Yeah.
they highlight what happens in that single line network if one of those wires breaks. They even show visually the connection between D and E getting cut.
Oh, so if someone just snipped the wire?
Yeah, and suddenly everything from A to D is completely cut off from E, F, and G.
Wow, so one little break can basically split the entire network in two.
Exactly.
Yeah.
So yeah, you might save on wires, but the whole thing becomes super fragile.
Yeah, any disruption and the whole thing falls apart.
Right. And that leads into the idea of a redundant network. Like that second example where everything's connected to everything. The idea is that you have multiple pathways between any 2 points.
So if one path gets blocked, there's a detour.
Exactly.
Yeah.
And that's basically what fault tolerance is.
Yeah.
Because there are multiple routes. If one route has a problem, the data can just go a different way.
Oh, that's so clever. So even if that wire at G breaks in the fully connected example, A can still send stuff to G?
Yeah, exactly. Might take a slightly longer route, but the connection's still there.
And the video mentioned that in the real world, you don't just have one failure at a time, right?
Oh yeah, it can be multiple things failing.
So this redundancy is super important.
Totally.
So then the first video gets into some practice examples, which I found really helpful.
Me too.
They show a network and ask, is this fault tolerant? And they basically show you how to trace paths between all the different devices.
Right, so if you can find at least 2 separate paths between any 2 devices, then you've got fault tolerance.
And in that first example they showed, it was fault tolerant. No matter which 2 devices you pick, there were always at least 2 different ways to get between them.
Yeah. But then they showed another one that at first glance looked pretty good. If you started at device A, it seemed like you could get to everything else in multiple ways.
Yeah. I remember that one. It was tricky.
But the key thing they emphasized was that you can't just look at one device. You got to check every device.
Right, because what happened?
Well, it turned out device F only had one single connection.
No, right. So even though A had multiple ways to get to F, if that one connection went down, F was totally isolated.
Exactly. So one weak link can make the whole network vulnerable.
It's a good reminder to always look for those single points of failure.
Absolutely. And then the third practice network they showed had this tricky thing where it seemed like there were multiple routes everywhere. But between A and G specifically, there was only one path.
Oh, right. So if that one link broke, A was totally on its own.
Exactly. So even though other parts of the network had redundancy, that one critical connection meant it wasn't truly fault tolerant.
Okay, so we've talked a lot about why fault tolerance is important, but the second Code Curious video really lays out what are the benefits of having this kind of system. And they remind us that the internet itself is a massive fault tolerant network.
Yeah, which is pretty amazing when you think about how huge and complex the internet is.
Right. And they specifically say one of the main reasons why fault tolerance is so good is because it gives you those multiple paths for data to travel. So like if one route gets clogged up or has a technical issue, or even if there's like physical damage, the data can just be rerouted.
Yeah, exactly. It's
Yep.
like having a backup plan for your backup plan.
And doesn't that also mean that the network can like grow and adapt more easily? Like it can scale, as they say.
Oh yeah, definitely. Because as you add more devices and more connections, you're basically increasing the redundancy. So more connections generally means more paths and better fault tolerance.
So like even though there are way more people using the internet now than there were like 10 years ago, it can still handle it because it's built with this fault tolerance in mind.
Exactly. And I use the example of like streaming videos, which we all do all the time.
Oh yeah, totally.
Like that wouldn't even be possible without a fault-tolerant network.
It's pretty amazing. And there was this interesting part in the video where they had a multiple choice question about the benefits of fault tolerance. And one of the wrong answers was that data only takes one route from one device to another, no matter the number of routes available.
Right. And that's totally not true.
Yeah, it's like they think the data just picks one path and sticks to it no matter what.
But the reality is much more dynamic. Like data packets can travel along different routes, and they often choose the most efficient path at that moment. But if that path gets blocked, they can just switch to a different one.
So it's like constantly adapting.
Exactly.
And then they showed another example of a network that initially wasn't fault tolerant. I think device A only had one connection, right?
Yeah, it was a classic single point of failure.
And the solution they showed was so simple, just had one more connection from A to B.
Yep. And just like that, you've introduced redundancy and made the network at least a little bit more fault tolerant.
It shows that sometimes even small changes can make a big difference.
Definitely.
So it seems like the takeaway here is that fault tolerance is like the foundation of any reliable network.
Totally. It's what allows the internet to function even when individual parts fail. And it's why the internet has been able to grow so much without constantly crashing.
It's all about redundancy, right?
Yep. Multiple pathways for data to travel, so there's always a backup plan.
Makes you wonder, like, are there other places where this idea applies?
Oh yeah, definitely. Think about like any complex system in your life. Are there any single points of failure? You know, one thing that if it breaks, the whole system goes down.
That's a really good question. And if so, are there ways to build in some redundancy to make it more resilient?
Exactly. It's a fascinating way to think about the world around us.
Thanks for joining me for this deep dive. Until next time.
Thanks for having me.